Hi everybody, this video is on using proportions in algebra. We have an example here of two stars and 3 hearts. And the ratio of stars to hearts is 2 to 3, which can be written in any of these ways. Note that none of these are the fraction that stars are out of the total or that hearts are out of the total. A fraction, you would need a 5 in the denominator describing the total number of parts, and 2 of them are stars, or 3/5 of them would be hearts, 3 out of the 5 pieces. Now, to get a proportion, you must have two ratios. You must have two ratios, and those ratios, in order to form a proportion, they must have an equivalence between them. So if we had a ratio of 2 stars to 3 hearts, and we said, oh, well, there might be 20, for simplicity's sake, 20 stars in another batch, and there were 30 corresponding hearts, this truly would form a proportion for a number of reasons. One is that everything in their relationships is the same. 2 is to 3 the same way 20 is to 30. You could say 3 times 10 would be 30. 2 times 10 would be 20, and that way it's just like fractions. But most importantly is the fact that the cross products, the numbers that when you multiply across, so say from 2 times 30, that is going to be equal to 3 times 20. You can check that. 2 times 30, 60. 3 times 20, that's 60. Okay, if this really is a proportion, the cross products must be equal. So there's a lot of applications for that, one of which is whether you can test to see whether or not something truly is a proportion very, very quickly. Okay, for a quick test on that, you might say to yourself, how do we know if this is truly a proportion? How do we know that for sure? So what I'd like for you to do right now is to test the cross products. Pause the recording for 1 second and write out the cross products of both of these two ratios. Go ahead. Well, if you went ahead and tested those out, you would have found 300 on this side, and 8 times 3 is 75 would be 3,000. So it's pretty clear there's something that's fishy here. So let's test it again. Let's do the exact same thing, but let's say it's 375 out of 1,000 this time. Go ahead and test it now. Okay, so hopefully without too much effort you notice that 3 times 1,000 makes 3,000, and 8 times 375 was 3,000. Therefore, these two are in fact equal. The cross products are equal, so this must be a proportion. These two things are proportional. Okay, so the greatest implication for all this is the fact that you can solve ratios very simply by using cross products. Now, a lot of you have memorized the thing that some people call the fish, which is essentially if you multiply 3 times 8 and you divide by 4, you must get x if that's equal. But I would prefer right now if you wrote 3 times 8 equals 4 times x. And you say, oh, 3 times 8, that's going to give me 24. So 24 is equal to 4x. You divide by 4, you get 6 is equal to x. And that should check. 4 times 6, 24. 3 times 8, 24. You know it's right. Now, the reason why I'd like you to write that out is because things start to get a little more challenging, especially when you have distributive property and another problem or two. This one here is fairly simple. Has a nice tidy answer. The next one, obviously, is a little different. It's still 3 to 4, but this is x to 7. So you can be pretty sure this is going to be a messy answer. It involves sevenths. So if you could kindly go and just write the whole thing out. So you're doing 7 times 3, and you divide by 4 is what your process is. That's what some of you can refer to as the fish. But please write it out. It's basically 4 times x equals 3 times 7. 3 times 7 is 21. That's equal to 4x, and you're dividing by 4, dividing by 4. So x equals 21 over 4. 4 goes into 20 5 times, so it's 5 and 1/4. So not that messy of a number. Still okay. X is 5 and 1/4. Of course, it makes sense to check, so you should take 5 1/4, plug it on in here, You can either do 4 times 5 1/4, see if it equals 21, 3 times 7, or you could do 5 1/4 divided by 7, and that should equal the same as 3/4, which would be 0.75. Go ahead and give that a test right now. Often you will have a sum or a difference in part of a ratio, sometimes it's in both sides of it, and that's where distributive property is going to come into play. It's also where there are limits on just simply saying 7 times 6 divided by 8 is x plus 3. You can still do that in this case, but when you have parentheses on both sides, that will no longer be an option for you. So, of course, you'll write this out. If everyone could kindly just go ahead and give that a shot, you're going to say 8 times x plus 3. That should equal 6 times 7 if this truly is proportion. If you could please write this down and pause the recording, just give it a quick run, see if you get the right answer, and check your work. Okay, with any luck, you came out with 2 1/4. X is equal to 2 1/4. And of course, to check that, you would want to say 2 1/4, 2 1/4 plus 3 divided by 6, and you would want to check to see is that equal to 7/8, which is of course 0.875. If you have that memorized, you'll know that, and it's a nice tidy thing to know. So 5 plus 2 1/4 is going to be 5 1/4 divided by 6. Go ahead and test that out. Okay, and hopefully if you tested that out, you'll find out that it does in fact equal 7/8, 0.875, and you are absolutely certain that you have the entire problem correct. Okay, so here's an example of a proportion where you must use the cross products to find out the solution. And then you'll also have to use distributive property across the parentheses. So go ahead, please write this as the cross products. Pause the recording, go ahead and write it out in your notebook. Okay, so what you should have could be on flip-flop sides, but it should look like this. 3 times the entire negative 2x plus 5 is going to be equal to negative 2 times the entire x minus 4. So right now, go ahead and use distributive property, pause the recording, and do the distributive property to get a equation that now has variables on both sides, but there are no parentheses because you've cleared them out using distributive property. Go ahead and pause now. Okay, so hopefully you have something that looks like this. You want to make sure that you take care of all the negatives here. So it's negative 2 times x, negative 2x, negative 2 times negative 4 is positive 8, 3 times negative 2x is negative 6x, 3 times 5 is 15. Okay, once again, these like terms, x's and x's, are not on the same side of the equation, so you must clear them out by using the property of opposites. I'm going to opt to add 6x to both sides. Okay, with the 6x added to both sides, I went with 4x plus 8 is equal to 15. Now I still don't have all my x's all alone. I have to get rid of this 8, get it over here with the 15, which is a like term. So I'm subtracting 8, and I'm subtracting 8 from both sides. Okay, so that'll give us 4x is now going to be equal to 7. And after we divide, find out that x is equal to 7/4, also known as 1 3/4, or 1.75. Now there are a ton of steps there, so it makes a lot of sense to take your 1 3/4 and just test it out. Put it back up in here and see if this side is equal to that side. Okay, please pause and go ahead and do that right now. Okay, so hopefully when you test it out, you were sure to use order of operations. You take the 1 3/4 and you put it in for x, you subtract the 4, get that answer, divide by 3. I think it came out to negative 3/4. And the same deal on the right, you're going to say negative 2 times 1 3/4 plus 5. Get your answer, then divide by negative 2, and that should match out at negative 0.75. Okay, for your first 4 homework questions, kindly work through these examples by using the cross products rules and check all solutions. So there are 1, 2, 3, 4 of them. Some of them are noticeably harder, So make sure you check your answers to catch all possible errors and be careful with negatives when using distributive property. Good luck. Okay, and for your last problem, a little bit of a challenge. You have two figures which are similar. This is my best attempt at similar. They don't look exactly similar, but it's the best I could do. Similar figures have proportional sides. So when you have something like that, if you had a star and another star and they were just exactly the same shape, the corresponding sides, this side would match up with that side. It would be exactly the same. So in this drawing here, we're talking about this side corresponds with this side. So similar figures have proportional sides. You know, the corresponding sides are proportional. So similarly, no pun intended, this side here is to this side in the exact same way. So this relationship will remain. X plus 5 is to 52.7, just like 3x minus 25 is to 87.5. And of course, the last thing would be 3x minus 15 is going to be to 4x plus 5 in the exact same ratio of length of side to the other. So one way is definitely more difficult than the others, so I suggest you plan your work carefully and then work your plan showing all your work. Good luck.